Our first question is, how do you build a transformer model from scratch? Building a transformer from scratch involves creating attention mechanisms, positional encoding, and layer normalization. Think of it like building a super smart translator that can focus on different parts of a sentence simultaneously. Like Google Translate understanding "I love cats" by simultaneously focusing on I as subject, love as verb, and cats as object to generate perfect translations. Remember this tip. Transform ER equals transform information with attention plus encode plus repeat. Summary. Transformers focus on multiple sentence parts simultaneously. Our next question is, how do you use HuggingFace transformers with Pytorch? HuggingFace is like a magical library of pre-trained AI models. It's like having access to thousands of expert translators, writers, and analyzers ready to work for you instantly. Want to analyze customer reviews? Just load BERT model and get instant sentiment analysis with no training needed. It's like hiring a team of experts instantly. Memory tip. Hug your models. HuggingFace gives you warm, ready-to-use AI models. Summary. HuggingFace provides instant access to pre-trained models. Our next question is, how is Pytorch used in reinforcement learning? Pytorch in RL is like training a video game player. The AI learns by trial and error, getting rewards for good moves and penalties for bad ones. It's digital evolution in action. Teaching AI to play chess. Each move gets a reward, plus 10 for winning, minus 1 for losing pieces. After millions of games, it becomes unbeatable. Remember, RL equals reward learning, like training a pet with treats, but for AI. Summary. AI learns through rewards and penalties like games. Our next question is, how do you use Pytorch geometric for graph neural networks? Pytorch geometric handles networks like social media connections. It understands relationships between people, websites, molecules, anything connected. It's like giving AI social intelligence. Analyzing Facebook friends. AI learns that if Alice likes coffee and Bob is Alice's friend, Bob might like coffee too. It spreads information through connections. Memory tip. Graph equals grip relationships. Pytorch geometric grips social connections. Summary. Geometric understands and analyzes connected relationship networks. Our next question is, how can you integrate Pytorch with OpenCV for vision tasks? Pytorch plus OpenCV equals digital eyes plus brain. OpenCV captures and processes images like your eyes, while Pytorch thinks about what it sees like your brain. Together, they create superhuman vision. Security camera sees a person using OpenCV, recognizes it's your friend Sarah using Pytorch, and unlocks the door automatically. Perfect teamwork. Memory tip. CV equals computer vision. Pytorch equals smart brain. Eyes plus brain equals magic. Summary. OpenCV sees, Pytorch thinks. Together they create vision. Our next question is, how do you interpret a CUDA out of memory error and fix it? CUDA out of memory is like trying to stuff too many clothes in a small suitcase. Your GPU ran out of space. The fix? Pack lighter with smaller batches or get a bigger suitcase with more GPU memory. Training image classifier with 1,000 photos at once crashes. Solution: process 100 photos at a time instead. Slower but successful. Memory tip. CUDA OM equals too much stuff. Reduce batch size first. Always. Summary. GPU memory full means reduce batch sizes immediately. Our next question is, how do you monitor GPU usage while training a model? Monitoring GPU is like checking your car's dashboard while driving. You need to know if your engine or GPU is running hot, using too much fuel or memory, or working efficiently. Stay informed, stay safe. Your GPU shows 95% usage. Perfect. If it shows 10%, you're wasting power. If it shows 100% with errors, you're overloading it. Memory tip. GPU monitor equals health check. Watch it like your heart rate during exercise. Summary. Monitor GPU like car dashboard for optimal performance. Our next question is, what are common mistakes made by beginners in Pytorch? Beginner mistakes are like learning to cook. You might forget to turn on the stove or GPU, use wrong ingredients or data types, or burn the food with wrong learning rates. Every master was once a beginner. Top 5 mistakes: forgetting to device like cooking on cold stove, wrong tensor shapes like square pegs and round holes, not using it backward like driving without mirrors, mixing data types like oil and water, forgetting modeled eval like training wheels during race. Summary: common mistakes involve devices, shapes, gradients, types, modes. Our next question is, how do you ensure reproducibility in Pytorch? Reproducibility is like having a recipe that creates the exact same delicious cake every time. You control all random ingredients, so your AI experiments give consistent results. 2 researchers run the same AI model. Without seeds, different results every time. With seeds, identical results always. Perfect for scientific papers. Memory tip: seed equals same every experiment done. 42 is the answer to everything. Our next question is, what are Pytorch extensions like torch scatter and torch sparse? Pytorch extensions are like superpowers for your AI. Torch scatter is super fast grouping. Torch sparse handles huge networks efficiently. They're specialized tools for specific superhero missions. Extension superpowers: torch scatter groups data lightning fast like sorting mail by zip codes instantly. Torch sparse handles huge sparse matrices like managing phone books with mostly empty pages. Torch geometric understands relationships like mapping friendships. Torch audio processes sound like perfect hearing. Our next question is, how do you measure inference time in Pytorch? Measuring inference time is like timing how fast your AI can answer questions. In real applications, speed matters. Nobody wants to wait 10 seconds for their photo to be recognized. Your AI takes 0.001 seconds to recognize a cat in a photo, lightning fast. But 2 seconds would be too slow for real-time video processing. Memory tip: time it equals test it. Always measure speed before deploying to production. Our next question is, what is the role of Torch manual seed? Torch manual seed is like setting your AI's DNA. It controls all random decisions your model makes, ensuring you get the same random results every time you run your code. Running your model without seed gives accuracy 85%, 87%, 83%. With seed equals 42, you always get exactly 85.7%, perfect for comparing different algorithms. Memory tip: seed equals same results guaranteed, like planting same flower seed always gives same flower. Summary: manual seed controls randomness for consistent experimental results. Our next question is, what tools do you use for Pytorch debugging? Debugging Pytorch is like being a detective solving AI mysteries. You need the right tools to find where your model is misbehaving and fix it quickly. Essential debugging tools: print statements are the classic detective tool to see what's happening inside. Tensored shape checks dimensions since most bugs hide in wrong shapes. Torch ISNN finds exploding gradients that break everything. TensorBoard provides visual graphs of training progress. PDB debugger steps through code line by line like slow-motion replay. Summary: use print, shape, ISNN, TensorBoard, debugger for investigations. Our next question is, how do you unit test Pytorch models and components? Unit testing AI models is like having a quality control inspector. You check each part works perfectly before building the final product. Better to catch bugs early than in production. Test that your image classifier always outputs 10 classes, never produces NaN values, and runs in under 0.1 seconds. Like checking a car before selling it. Memory tip: test early, sleep easy. Better 10 minutes testing than 10 hours debugging. Summary: test models early prevents expensive production bug fixes. Our last question is, what are key differences between Pytorch and Pytorch Lightning? Pytorch is like cooking from scratch. Full control, but lots of work. Pytorch Lightning is like a smart kitchen assistant. Handles boring stuff so you focus on the creative parts. Pytorch means you write training loops, GPU handling, logging everything manually. Lightning provides automatic training loops, multi-GPU support, logging, callbacks all built in. Code reduction: 1,000 lines Pytorch equals 200 lines Lightning. Best choice: learning equals Pytorch, production equals Lightning.